Welcome friends. Today we are going to discuss an important topic on carbon capture, utilization and storage. We'll also briefly discuss about why it is important to capture the carbon dioxide in the atmosphere. So to go into the details of why we have to capture the carbon dioxide in the atmosphere, we have to know a little bit about the global warming and greenhouse gases. So what is causing the global warming? We are seeing the many analysis reports, news items that atmospheric temperature is increasing, and in the last 100 years alone it has increased 1.5 degrees, and if it reaches 2 degrees it is very catastrophic consequences are going to be there. So what causing this global warming? So global warming is caused by the trap of heat entrapment in the outer atmosphere by the layer of gases, which are not allowing the reflected heat to go out of the atmosphere. So it is trapped into the earth surface, Earth's periphery, Earth's atmosphere. So they are called greenhouse gases. So main constituent of greenhouse gases is carbon dioxide, but there are other gases like methane, and there are CFCs, chlorofluorocarbons, which we are familiar with using in the refrigeration circuit. So the old refrigerants and all from these CFCs, okay, they have very huge potential to cause damage to the ozone layer, and also they are like greenhouse gases. So the carbon dioxide is the chief constituent of the greenhouse gases, which is causing the global warming. So efforts are on to reduce or if possible stop the emission of carbon dioxide by various man-made activities into the atmosphere to stop the global warming. So what happens if the global warming happens? So we are going to see what are the bad effects of global warming. So see, the globe is getting warm, you will find hot surfaces on both on the ocean and the earth surface. There will be more severe storms and more frequent storms. So we are already seeing last 10 years, atmosphere has fully changed and more cyclones were coming, and more intensity of cyclones were coming. So, and some part of the globe also can experience very severe famine and drought, temperature can increase. For example, this year, Europe summer touched 40 degrees temperature, which is not happened last 10-20 years. Another disastrous consequence is rising of the oceans. See, when the temperature of the atmosphere increases, the very delicate glaciers, ice glaciers were there in the North Pole and even in Himalayas. So those ice caps will melt. Huge amount of water is going to form. It will find its way into oceans. So the average ocean level will increase by an estimate close to 800 mm, and even worst case it can even go to 1000 mm. So 1 meter rise in the sea level means many cities get submerged. Around the world, it is estimated 96 countries where these cities were there, like Sri Lanka, Bombay, New York, many other cities. There will be huge migration of the population from those cities to other places. So it's a disastrous consequences. And also some animal species and plant species cannot withstand even this minute increase in temperature. So it is estimated that 10,000 of species going to extinct. So an estimate, currently the scientists estimated there are 1.5 million animal species and 450,000 plant species that is identified and known. There can be some more unknown, but out of this 10,000 species are going to be extinguished as an estimate. So one example is we have a kind of turtles in the Orissa coast. They are facing this threat. There is another threat. Yield in the crop is going to come down. There is an ideal percentage of carbon in the atmosphere which gives good yield of the crop. say, let us say rice, 1 acre, we are getting some 40 bags of rice now. Now the atmosphere is disturbed, then the crop yield can come down to, instead of 40 bags, it will become 25 bags. So the crop yield becomes less. There will be shortage of food and kind of we'll see very bad situation. Then this increase in temperature also responsible for increasing the tropical diseases. So more health risk for the humans and even animals. So all this will result into a huge displacement, poverty, and unemployment. All this will be catastrophic to humankind and plant and animals. So all our scientists were advising us to try to limit the emission of carbon dioxide into atmosphere and limit the temperature rise to 1.5 degrees only, not go to 2 degrees. So one way is not to release more CO2 into atmosphere. Other way is capture back the CO2 in the atmosphere. Already CO2 we are releasing, but don't release it to atmosphere. From our application, you capture the CO2 and make it a solid carbon or a liquid carbon, which is a valuable product which can be used in paints and other applications. So capturing CO2 is gaining increasing importance. So what is the current levels? The current level of carbon dioxide in Earth surface, Earth atmosphere is 412 ppm, parts per million. So which is very high. So if it reaches 450, we will see all that disasters happening. So we should somehow limit, it should not reach 450 ppm. Actually, if you see, the gain is very fast. In 2000, that is 22 years back, the atmospheric CO2 is only 270. In short 20 years, it increased 50 percentage points, 50 points. So it is like 47% increase. 370 to 412. It is a steep increase in 20 years time. Then what is the ideal level? See, we are also at the same time CO2, some amount of CO2 is desired in the atmosphere, because we know all the plant matter, that fruits, leaves, all the fruit plant produce is in the form of hydrocarbons. That means hydrogen and carbon is the main ingredient in any fruit or a leaf or any growth. So CO2 is taken from the atmosphere by these plants, and the energy required for this conversion, photosynthesis, is taken from the solar radiation, sun radiation, sun energy it will take. It will absorb the CO2 from the atmosphere, and it will take the required hydrogen from the water, which we will pour to the plant, or it will atmosphere, it will absorb from the soil. So if the enough carbon is not there, then also crop yield will come down. So ideal, what is ideal? So mankind has thrived for so many million years with the carbon dioxide at a ppm level of 280 to 350. So 300 we can say is ideal level of carbon dioxide to have in the atmosphere. So now from the current 412, if it's possible, you should reduce to 300. Then who is contributing to this CO2 emissions? This is the statistics for India. In India, most of the electricity is generated using burning the coal. So carbon, when you burn with the atmosphere, the help of oxygen, C plus O2, CO2, carbon dioxide. So more than 50% of the carbon dioxide emitted in India is from the power sector, power industry, mainly coal and some extent gas-based industries. So what is the alternative to wean away from the burning of the coal? Generate power from the non-coal sources, non-methane sources. Means we should do more of a solar PV, wind, hydro, such renewable energy. Government is actively encouraging to set up more non-conventional energy. We already reached installed capacity of nearly 25% of our installed capacity. We have 4 lakh megawatt of power installed in this country. Around 1 lakh megawatt is installed capacities from the various renewable energy sources. And solar is very dominant in that. Maybe 60% is solar, maybe some 30% wind and some hydro and all other 10%. So power is the major contributor. Then not far behind is we have a industries. Industries consists of a fertilizer industry, cement industry, steel industry. These, when the process of making a steel or cement is highly carbon intensive. When you produce 1 ton of steel, you have to burn 1 ton of coal. There is a huge carbon emission from the making cement plant, energy intensive process. Similarly, we have other next contributor is transport. Transport vehicles, cars, trucks, lorries, all invariably burn the fossil fuels and emit lot of CO2. So, to reduce the transport related emissions, we should switch ourselves to EV, more and more EV. Government is increasing more and EVs, but the electricity required for charging those EVs shall come from the solar PV, wind and renewable sources. They should not come from the coal-based power plant. So, more EVs with renewable energy for charging. That is the ideal situation. Then we will be able to limit the 10% what currently have transport CO2 emissions to maybe less than 2% or whatever. So then, not well known, but it is a fact that buildings contributing 7.5% of the total CO2 emissions. Building will have a lot of air conditioners, lights, fans, so major appliances. All this consume energy. That energy is coming basically from the coal. So that's why huge amount of energy spent in the maintaining the buildings. So buildings are advised to install rooftop solar and other means to reduce the energy from the coal-based power generation. So we can reduce the transport base. So what are the current CO2 emissions in India? In 2006, if you see, it is huge figure. It is like it is more than a few crores of tons of CO2. It is 2533, 638, 100 in tons. So much CO2 is in one single year India has emitted. So let us see how much CO2 is produced by burning 1 kg of coal. Coal represented with the carbon C. So if you put a little chemistry of it, so C has a molecular weight of 12. Carbon, if you burn in the atmosphere, it will take oxygen, which is molecular weight of 32, C plus O2, CO2. So 12 kgs of CO2 is producing 44 kg of CO2. Then 1 kg of coal will produce 44 divided by 12, that is 3.6 kg. That means if you burn 1 kg of coal, you are emitting 3.66 kg of CO2. And if you take instead of carbon coal burning, if you burn petrol or diesel and petrol has no chemical formula because it is not a homogeneous chemical. So one chemical which represents octane, petrol, is C8H18. So if you burn that chemical, we get into CO2 and H2O. So if you backwork that, how much of this chemical produces for 1 kg of this chemical burning, we'll get into 3.08 kg of CO2 per 1 kg of petrol or diesel burning. So nearly 3 times. What are our emissions? India is emitting per capita, means for each population, for each and every citizen of the country, the average emission of carbon dioxide per capita, it is called per capita income. So per citizen, it is 2.4 tons equivalent per year. CO2, E means equivalent. It can be CO2 or other greenhouse gases. If you convert everything to CO2, it will be 2.4 tons of carbon dioxide per year. For each human being living in India is average generating 2.4 tons of CO2. World average, worldwide it is high. We are nearly 3 times our average, 6.3 tons CO2. US is generating for every citizen 14 tons of CO2. Russia is 13 tons, very close. China is 9.7 tons. China also hugely populated like ours, even though their per capita is only 9.7 tons per year, but since they have a population of 1.130 crores plus, so it is, if you consider so much population, the amount of CO2 generated by China is very high compared to US, because they are having less population, even though per person it is 14 tons, since the population of US is like 1/3 of India. So their total CO2 is not very high, even though they are consuming 14 tons. So there is another reason why China is much higher is China is world largest factory. Many of the goods required in the world are manufactured in China in huge factories. So the world manufacturing facility, many manufacturing facilities were there in China. So the manufacturing the steel and the cement and other industrial goods generate lot of CO2. That's why China has become world largest CO2 emitter. Nearly 30% of the world CO2 is emitted from the China. Next, US at 13%. We are also not better. India is the third largest emitter of CO2. That is a fact. So how the trend is? Next is everybody interested how year after year we are how much whether CO2 emissions from India is increasing or decreasing. Unfortunately, it is increasing. 2008 we emitted 1498 million tons. So every year it is increasing. Currently it is hovering around 2600 million tons of CO2 emitted per year. So we want to slow down this increase, at least maintain a rate, and want to bring back to pre 2005 level, maybe which is at 1300 million tons or so. We want to reduce our carbon emissions. So India has argued that we have a lot of population, so our CO2 emission is naturally large. So then they asked for, you compare with our GDP, gross domestic product, for each 1000 tons of $1,000 of GDP, how much CO2 is produced? That is an interesting fact. For 1000 to generate $1,000 GDP, how much CO2 is produced? That will meet, like that India has told. Let's see that picture. This is that picture. The for $1,000 of GDP produced in India, we are consuming something like 0.34 tons in year 2008. Luckily, this value is coming down year after year. 0.34, 0.32, 0.3, 0.29. Now we are at 0.28. So for $1,000 of GDP production, we are consuming 0.28 tons of carbon dioxide. We are producing that much. So year after year, it is reducing. It is a welcoming fact. So we want to bring down to further, maybe less than 0.2 we want to become. Then what is the solution? So we are not able to stop the emitting of CO2. So we can become net zero. Means we won't completely stop emitting CO2, because even though all industrial processes were taken away from the CO2 and use some other fuel, there is still one more component coming from the natural phenomena. So man is inhaling, it is taking oxygen and inhaling out CO2. So animals are inhaling, plants are inhaling and giving out CO2. That CO2 is difficult to stop. Industrial process we can invent some other process stop, but natural process. And also in the animals, when they eat and digest hydrocarbons, CO2 is reducing, is getting generated in the stomach of the animal. It is coming out. So some 5-6% of CO2 still will be generated. So how to become zero then? We have to capture the CO2 from the atmosphere. How much we are generating? How to capture? One easy method is grow more trees. Each tree will consume some amount of CO2 to make the fruits and all. It will take the atmosphere CO2 and reduce the CO2 in the atmosphere. So that way, if you have more and more trees, CO2 absorption from the atmosphere takes place, and we can become net zero. India is committed on the recently concluded COP, Confederation of Parties 27. That meeting happened in this November, and India is committed to become net zero country by 2070. So gradually we have to stop our industrial process from using carbon related products, maybe going to hydrogen. So this is the way. This is prominently figuring in UN sustainability goals. There are 17 sustainability goals. Unless everybody follows this, it is very problem for the mankind to even survive. So it's called it sustainable goals. So these 17 sustainable goals will help in humankind to survive long. Otherwise, it can face extinction. So one of the goal in this is clean energy. Clean energy can be generated not from the coal or methane. It is from the renewable sources like hydro, water, and nuclear. So what should be our targets? So in one day we cannot achieve. Over the years we have to achieve. See, we are saying we will become net zero by 2070. So we should start to try to do it by 2050 so that we will reach at least by 2070. So the internal, even though world we told 2070, internally we are trying to do it by 2050 itself. By 2050, we want to do like this. So forest, land, agriculture, the generation from this we cannot curtail because it's a natural process. The 72% will be coming from those sources. Power, we want to 100% stop generating from the carbon-based emissions. Cement, we want to move 90% of the cement from the carbon-based to some other hydrogen-based this thing. Iron steel production, we want to do without carbon this cement production and also steel production by using the direct reduction using hydrogen. And also we want to generate all the electricity for the buildings from the solar PV and other renewables. So 99% of our building shall be not using the grid power. They should use the solar PV by the year 2050. Even we are targeting both the service buildings, that is commercial buildings, and also residential buildings. So breakup of CO2 emissions, currently we are emitting every year 2.6 GPA. 2.6 GPA means gigatons per annum. 2.6 gigatons per annum of CO2 we are emitting. The breakdown, if you see, industry is contributing around 31%, agriculture 20%, and transportation 10%, and buildings 5%. But this is going to go up. LCT is another 30% overall, if you see. So two scenarios are projected here. 2020 currently how much it is, and in short term, next 10 years we should plan. We should have a short term plan and a long term plan. In 2030, how much we are going to reduce, or we are going to reduce or not. Unfortunately, the picture shows it is not reduced. The CO2 emission from the 1621 to going to go up to 2291, but growth is not too steep. So little increase, say it is like 50% increase. We want to curtail at that level. So breakup of power, the power generation continue to be on the coal till 2030. So the 1000 becomes 1200. So cement and steel we want to produce from the non-conventional energy resources. So there is a some progress we achieve by 2030. So what is the internal commitments by the government of India? Government of India want to reduce our intensity of the GDP by 45% by 2030 from the 2005 level. So 2005, let us say we are contributing 1300 million tons of CO2. We want to, now we are contributing nearly to 2500 million tons. We want to bring back to 1300. So nearly 50% reduction, that is 45% reduction by 2030. So if you further work out the detail, we have to reduce 0.5 metric tons of carbon dioxide for every $1,000 GDP. Okay. So like that we have internal targets. There is another way, grow more trees so that CO2 in the atmosphere can be absorbed by these trees. So you create a carbon sink, means grow some 2.5 to 3 billion more trees so that additional carbon dioxide generated is consumed by these trees. So it will be like net zero. Now let us look at what are the technologies available for absorbing the CO2. Okay. So one preferred mode is, there is called SMR, steam methane reforming. There we can capture the CO2 as a part of that production of methane. The byproducts of carbon dioxide can be absorbed in a chemical. The second method is physical solvent, solvent based. We have a solvent and send the CO2 into that, it will absorb that. Again, from this absorption, you separate out carbon as a liquid or a solid and store it for further use. Then there is one adsorption, not absorption, adsorption, which is a surface phenomenon. On the surface of this catalyst CO2 is absorbed, then that will be recycled for generating liquid CO2 or a solid CO2. There is fourth method of cryogenic capture, means you have to cool down that substance so that CO2 gets separated and make it into a liquid CO2. Cryogenic method, it is slightly expensive. So if you see various methods cost, in one particular method rupees 400 per ton. In the extreme method, it is like 4,000 rupees for capturing 1 ton of CO2. So the refinery chemical based process is very expensive, 4,000. The gasification based method is less, 400 rupees per ton. So same thing was put in the tabular fashion. So here they are talking about the total cost. If you see a total cost of any process, first it will be two parts. First part is the cost of equipment, land, building to set up that process, that plant. That is the initial cost. Okay. There is a cost component which is recurring. So to run that plant, we have to spend energy, we have to hire people. So that running recurring expenditure, that is called running cost. Whenever we calculate a cost, we should calculate the total cost. So total cost of the capture of CO2 was listed in this last column of the table. So it is some 400 in one process, 18 in another process. For example, the CO2 making, the cement making plant, you want to capture the carbon, it is nearly costing 2,000 rupees additional for each ton of cement produced. So like that, different processes has different costs. So power plant, we want to set up a 800 megawatt power plant with the carbon capture. We have to, for each ton of CO2 captured, we are expenditure is coming to 2,800 to 3,000 rupees. So so much money need to be invested to capture this carbon dioxide. So if so much carbon is captured, where to store? There will be huge volume required. So what scientists thought is we can store this CO2 in underground mines. So they already identified in Indian map locations where the big underground mines, hollow mines are there, where we can store this captured CO2. If you see, we have in the Indian map, northern region, we have a potential to 7.21 gigatons of CO2 can be stored. Captured carbon can be stored. And even in the northeast, we have 0.22 gigatons. And southern region, so we have around 9 gigatons of CO2 capture possibility is there. But Madhya Pradesh, we have a lot of underground mines for there. Maybe they are earlier coal mines. Coal was extracted, that mine is still empty. You can put the carbon back in that. So that is very good idea to store this carbon in these mines. So if carbon is not used, carbon dioxide not produced, so that the work of carbon, the heat produced from the carbon has to be done by some other agent. So people are hoping hydrogen one day will replace this carbon. Currently, hydrogen, if you burn, will produce only water vapor, H2O. So it is not a pollutant. So one day people want to migrate all our energy intensive process to hydrogen. So, but currently it is very expensive. Now a green hydrogen cost is something like $7 per 1 kg of hydrogen. Whereas coal based same energy to produce will cost less than $1. So a lot of money currently it is costing to hydrogen. So now technology we have to develop to make this hydrogen process cheaper. So that time we can migrate to completely hydrogen. Technology not yet matured. So a lot of research work is happening to produce hydrogen at a cheaper price. So we are all studied in the school or college that hydrogen, we know all, is a colorless gas. It do not have color, it do not have any odor also. But industry may people talk about green hydrogen, black hydrogen, blue hydrogen. What is then color for hydrogen? So this color is not that how it looks like, but it is actually the process of making the hydrogen, how hydrogen is made, in which process hydrogen is made. If you use a process from which raw material hydrogen is made, based upon that, the color of hydrogen was named. Suppose you make hydrogen from coal, then it is called black hydrogen. Suppose you made from lignite, then it is called brown hydrogen. So suppose you make hydrogen from coal or methane, but you use a carbon capture technology, CCUS, to capture the whatever CO2 produced, then it is like clean only. So that is blue hydrogen. This is more acceptable. Then suppose you don't use any coal, you use completely by electrolysis, use the water to produce hydrogen, send current in a limited way to separate hydrogen and water in a electrolytic cell, then that hydrogen is very clean hydrogen, then that is called green hydrogen. There is a great demand for green hydrogen. So alternatives, what alternatives are available for producing the for stopping the carbon dioxide emitting into the atmosphere? So the alternate process is carbon capture and utilization. So you use coal for your coal plant, but capture that carbon dioxide coming to the power plant, don't leave it to atmosphere, absorb that CO2 and convert it into solid or a liquid C and use it for industrial application. Then it is called a green process. Let's see an example. Suppose a bus is operated with 1 kg of diesel. Okay, so that bus taking 1 kg of diesel, and also because of there is air fuel ratio, 1 kg of diesel requires something like 13.73 kg of air to burn completely. So that was done in an IC engine. So all the energy produced in that engine is not getting into mechanical power. PM is mechanical power. Only 1/3 of it is converted into mechanical power. Rest is various losses like coolant losses and something going to atmosphere. The exhaust gas, if you see, majority of the exhaust gas is nitrogen. Nitrogen is something like 68% of the exhaust gas is nitrogen, and we have 12% CO2. But if you can successful in capturing this 12% CO2, we are successful. So if you capture that 12% of CO2 from this 1 kg of diesel, you are going to get very close to 2.11 kg of liquid carbon dioxide, and that process could be at 75 bar and 25 atmospheric temperature. So it's very high pressure, only you can make this CO2 liquid. So is there a real plant? All is in only paper. So yes, there is a real plant. We have in India one NTPC, National Thermal Power Corporation plant, 500 megawatt plant. They have tried experimentally to capture the CO2 from this exhaust gas. They set up a 20 ton per day capacity, 20 tons of CO2 from the stack. Partially some quantity of CO2 they are absorbing, and the absorbed CO2 they are again converting into methanol, which is a fuel for we can mix in the petrol and diesel. So they are from this 20 tons of CO2, they are able to generate 10 tons of methane and using a catalytic hydrogenation process. So if this process is successful, and it is already successful, but lot of energy is required to do this. So one day if the lot of solar PV energy is available, so we should encourage this plant to generate more and more this alcohol, methyl alcohol, CH3OH, its chemical name. So that is a fuel, this raw feedstock also for making ammonia and other things. So it's a very good process. So finally, we has to see this as is it a curse or is it an opportunity? So they are looking at both ways. So we should, if we think of this is an opportunity, we have to absorb 75 million tons per annum of carbon dioxide by 2050, which can generate nearly 10 to 10 million full-time employment. Means 8 to 10 crore employment generation is possible just by the single technology. So that is the opportunity, but we have to do a lot of expenditure on that. That is a kind of a curse. Otherwise that money can be spent on healthcare services, education, other thing. But since we will spend this money, government is committed to spend this money to generate additional employment and to keep the globe clean, to keep the atmosphere clean, so that survival itself will not be a problem. Thank you very much, and we'll continue in the next section on the further aspects of this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.